Welcome back, chemistry students. This is a step-by-step practice of a grams to grams conversion problem. So throughout this video, I am going to encourage you to stop and pause. Solve the next step, then hit play. If I am talking too slowly for you because you're feeling wonderful at this, turn the speed up. You're on YouTube. It's easy to just turn me up to a faster speed to make me get over with quicker. All right. Next step, or the first step here, identify the type of reaction. What type of reaction do you see below? A blank of aluminum oxide type of chemical reaction. So you see here, press pause and figure out whether that is synthesis, decomposition, single replacement, double replacement, or combustion. Press pause now. Assuming you took that break, this is a synthesis reaction. You know that because you're seeing aluminum combined with oxygen to form aluminum oxide. You're going from two more simple reactants to one more complex product. Next step, I'd like you to balance the reaction showing your work. So press pause and stop to balance it. Show your work in case that needs to be demonstrated by dividing it up down below into aluminum and oxygen. Press pause and solve. All right, welcome back. The solution for this, aluminum, you only had one. If we assume the coefficients were 1 to begin with, you only have a single aluminum. You have 2 oxygen. You have 2 aluminum on the product side. And 3 oxygen on the product side. Your aluminum is out of balance. Your oxygen is out of balance. You can tackle either one. I'll go the long way in case that's the way you went. I'm going to tackle aluminum first by changing this to a 2. Our coefficient in front of aluminum on the reactant side to a 2. That brings that to a 2. It looks like your aluminum is in balance. But then when you try to tackle the oxygen, you're going to see, whoops, my 2 can't get to a 3 because we have to multiply by whole numbers. My 3 can't get to a 2 because it's less than it, so I can't multiply by a whole number to get smaller. So I'm going to cross multiply them. Make them meet at the middle. Get rid of each of those coefficients. I can get my 3 to a 6 by multiplying aluminum oxide by 2. I can get my 2 oxygen on the reactant side to 6 if I multiply the O2 by 3. Let's make sure that works. 3 times 2 gets me to 6. Aluminum, 2 times 2, that brings my aluminum up to 4. And 2 times 3 gets me to 6. That was good for my oxygen, but whoops, that's what I meant by the aluminum going out of balance. So I'm going to get rid of the coefficient of 2 on the reactant side for aluminum and make that a 4 instead. Now I have 4 aluminum, and 2 times 4 is aluminum. 3 times 2 oxygen, 2 times 3 is 6 oxygen. We're balanced. Next, take a moment to read that. Highlight and underline your given. Highlight and underline the thing you're trying to solve for and label those. Assuming you did that, hopefully you did. 1,000 grams of aluminum oxide. That is your given. How many grams of O2 will be required? That is what you're solving for, grams of O2. They are both grams. They are both mass. So again, we need 3 conversion factors to do this. The conversion factor we're going to need, 3 conversion factors. We start with what we're given. We go from grams of Al2O3 to moles. Al2O3. We go from moles Al2O3 to moles O2. We go from moles O2 to grams O2. 3 conversion factors, 1 for each of those arrows. First one, just like before when we solved it for that Martian problem, it's going to be using molar mass. Second arrow is coefficients from a balanced chemical equation. Third arrow is molar mass. Now for these, it does need to be slightly customized, right? This is molar mass Al2O3. The coefficients part doesn't change here. We just have to make sure we get it for the ones in question. The last one is molar mass of O2. All right. I would like you to try to pause and set this problem up. Try to give me whatever your starting amount is, you're given, times a conversion factor, times a second conversion factor, times a third conversion factor. Set that up with the units only. Don't give me numbers, just give me units. Press pause to try that. All right, welcome back. Let's see how you did. First, my given, grams Al2O3. The next conversion factor is going to have grams Al2O3 on the bottom. And is going to have moles Al2O3 on the top. The next conversion factor is going to have moles Al2O3 on the bottom and moles O2 on the top. The third conversion factor is going to have moles O2 on the bottom and grams O2 on the top. Make sure they cancel, so I know I set this up right. Grams Al2O3, grams Al2O3. One on the top, one on the bottom. Moles Al2O3 on the top, moles Al2O3 on the bottom. Moles O2 on the top, moles O2 on the bottom. Grams O2 survives. That is what I'm trying to solve for. Looks like I set it up correctly. All right, now for the numbers. Go ahead and pause once you know you have that set up correctly. And let's see if you can give me the given. Solve for the molar mass of Al2O3. Solve for bringing down the coefficients for this middle. And again, solve for molar mass of O2. So let's do that in smaller steps. Start with giving me the given and solve for the first one, molar mass of Al2O3. All right, assuming you paused and tried that, your given was 1,000 grams of aluminum oxide, so I need to write 1,000 right there. The next step on that quick pause was to determine the molar mass of Al2O3. For that, I need aluminum times 2, because it's Al2. And I need to add that to oxygen times 3, because this is O3. From there, I just need the numbers from a periodic table, and I copied those in for quick reference. The Al is going to be 26.982 times 2 plus 15.999 times 3. Solve that out, and you will end up with 100 100.961 grams per mole, or grams per 1 mole. From here, I'm going to transfer those numbers up. 100.96 grams, I'm going to put where the grams are. The mole is really 1 mole, so I'm going to put that up where the moles unit is. 100.961 grams, 1 mole. All right, pause for a moment. Bring down the coefficients from a balanced chemical equation into the appropriate location in this conversion factor. All right, on the top is O2. I have a 3 O2 in my balanced chemical equation, so I want a 3 there. In the denominator is Al2O3. Finding that up in the balanced chemical equation, I have a 2 in front of that molecule. So bring the 2 down to this conversion factor on the bottom. Last step of the conversion factor setup. Pause again to figure out the molar mass of oxygen and figure out where you put the numbers in the conversion factor. All right, welcome back. That should have been oxygen times 2. Oxygen was 15.999 times 2 gives you 31.998 grams per mole, or grams per 1 mole. Which means I want the large number, the grams, up on the top of the grams. It's 31.998 per 1 mole. 1 goes on the bottom. Take a moment to condense that or solve it all the way through. So take a moment to condense your numerators and denominators or solve it all the way through. Press pause now. All right, the condensed version would look like this. 1,000 times 1 times 3 times 31.998. In the denominator, it would look like 100. Oh, missing my 1. 100.961 times 2 times 1. Solve those. On the top, you end up with 95,994. In the denominator, you have 200.922. Solve that one last time, and you end up with 475. What are my units? The units should be the only thing that survived the canceling up above. There's going to be grams of O2. Again, pause to make sure that makes sense. You're looking for the amount of one of your reactants to produce a given amount of product. 475 is less than the total amount of product. That's good because I only have one product. And aluminum is quite a bit heavier than oxygen. So it makes sense that more of that 1,000 grams would come from aluminum than would come from oxygen. Even though I have 3 oxygens there. Alrighty, that is that. You guys are becoming stoichiometry pros. My students, you have one last practice problem to do on your own. I just ask that you take the time to set it up just like this, purposefully, and the habit will hopefully be ingrained. Good luck.